Well, welcome everybody. We're just going to give folks a minute to get in and get settled before we get started. Alrighty, well, it looks like we've broken triple digits for the folks that have joined us today, so I'm going to take that as my cue to go ahead and get started. Good afternoon, depending on your time zone, good morning, everybody, and welcome to our very first bootcamp session of the Run on Less Messy Middle series. It feels like just yesterday we were signing off our final session for the Run on Less Electric Depot Bootcamp series, but I want to welcome you all back for another exciting and educational series. My name is Rachel Ellenberger, and I'm the Industry Engagement Manager for the North American Council for Freight Efficiency, and I will be the moderator for each of our bootcamp sessions this year. Next slide, please. So before we get started, I would like to thank ACT News for hosting and providing all the technical support that we need to make these sessions possible. We've had a very long-standing partnership with ACT News, and we appreciate all of their support in helping us put these together. Next slide, please. I would also like to remind everybody that the ACT conference is coming up soon, so be sure to register as soon as you can. NACFE always enjoys attending. We have quite a few staff members going this year. Our booth number is here on this slide. So be sure to use the promo code on the screen to receive a registration discount. The conference will take place at the end of April, and it'll be back in Anaheim this year, so we hope to see you guys there. Next slide, please. So Run on Less Messy Middle is dedicated to exploring the alternative fuel and advanced vehicle technology solutions for Class 8 long-haul trucking specifically. When we were planning this series, we noticed that there was a lack of common language around long-haul Class 8 trucking. And earlier this month, we actually published a white paper titled A Need to Redefine Class 8 Long-Haul Trucking. This report is free to download on the NACFE website, and we'll be using the definitions that are outlined in this report throughout Messy Middle. Next slide, please. So this is the very first session of our series this year, and this year looks slightly different. Because we're covering so many technologies and fuel types, we're organizing our content by fuel unit, and each unit has 3 sessions that look a little bit like this. It's going to include panel presentations and some time for Q&A at the end. You'll notice that there is a final workshop that's going to be structured differently. The workshop will be 2 hours instead of 1, and it's going to be hosted by our Executive Director, Mike Roth. And during these workshops, we're going to dig a little bit more into what we heard during those sessions. We're going to hear from some new folks. We're going to see new faces, have a couple of breakout sessions where our attendees can chat with one another and NACFE staff and others to share information and collaborate. Now, space for the workshops is limited and is by invitation only. In order to be invited to the workshop, you'll need to attend at least one of the sessions in that unit. So everyone that's attending today is already set to go. Next slide, please. And now I'd like to turn it over to our Executive Director, Mike, with a quick update from the run. Mike.
Yeah, hello, everybody. Boy, it's exciting to kick off really the activities today of our 5th Run on Less effort. I remember back in 2016, a few of us were sitting around talking about what else could NACFE do besides write reports and a few things, and Run on Less was born in sort of a brainstorming session. And in 2017, we gathered 7 truckers that were from 7 different fleets. So 7 drivers, 7 different fleets. They brought their best new tractors and trailers and equipment. They incorporated, the best practices, and they did 10.1 miles per gallon in long haul over the road operations. And, I remember standing up in Atlanta announcing that 10.1 number, and I was just so excited and actually a little shocked. I was expecting it to be in the low 9s or around 9 mile per gallon. So we discovered there right away that the best of the best were doing some extraordinary work. And fast forward now, we've done Run on Less regional with diesel and a natural gas truck. We've done 2 run on less electric runs in 2019 and or 2021 and 2023. And this boot camp series, or just allowing us to host experts to talk about these topics, has been a huge hit, and evidenced in all of you joining today and kicking this off. So thanks for your participation. This boot camp series is going to be a lot of fun, and I would encourage you to return for that workshop. That'll be in 2, 4, 6 weeks from now. And it'll be a way for us to kind of wrap up the first 3, and then we'll move on to battery electric and hydrogen for the rest of the series. We're also working hard on finding fleets that want to participate in the run in September, where we'll stream data from the trucks and do tons of interviews with the people making each of these different technologies work in their operation. So I just wanted to welcome everybody and remind everyone that Run on Less is grounded in the real world. This is real trucks, real routes, real freight. We're not, like pre-scripting what you'll see in September. So stay in touch with the run, and I'm glad you're here, and I'll turn it back to Rachel.
Awesome. Thank you so much, Mike. And Stefan, if we could go to the next slide, please. So I have a quick few bits of housekeeping before we get started, and I promise I'll make this fast. We can turn over the majority of the rest of the time to our speakers here. But first and foremost, I would like to thank this session's sponsor, ExxonMobil. Thank you so much for your sponsorship to help make this series possible. Next slide, please. So we are doing quizzes again this year, and this quiz will be available online immediately following this session. This is going to be your opportunity to test the knowledge and the things that you've learned from this session. Once you successfully complete this quiz, this year you're going to have the option to fill out a Google form to provide your contact information and be entered into a drawing for a Run on Less Messy Middle swag bag. The drawing will happen at the end of the boot camp, and there's going to be a limit of 1 entry per successful quiz completion with a maximum of 9 entries. To access this quiz, just go back to the landing page for this session on runonless.com, and you'll see the button to take the quiz. Next slide. And our final reminders here, this session is going to be recorded and will be available online later this week. If you didn't get a chance to submit a question on the registration form and you would like to do so, please use the Q&A controls in the upper right-hand corner of your screen. During the Q&A, I'm going to relay your questions to our speakers, and for those questions that we don't have time to or we won't be covering in this session, we're still going to be collecting them for future content. So if there's any content that you're curious about, make sure that you send in your questions. And finally, if you run into any technical issues, please be sure to reach out to Stefan Babcock, who is our contact at ACT News, and he will help you troubleshoot. Next slide, please. And with that, let's go ahead and get started. I'd like to introduce you to today's panel. First, we are going to hear from Jeff Seeger, who is a clean energy consultant on our team with NACFE and our very first presenter of the day. Jeff, thanks so much for joining us. I'll turn it over to you.
Great. Thank you, Rachel. Okay, good day to everybody. If you could advance the slide, please. I think we've all heard about the pre-buy, potential pre-buy in 2027, and prices increasing on the vehicle. We won't so much talk about whether or not there's a pre-buy or the prices, but would like to talk a little bit around the technology and what's changing that's driving these changes. So if you go to the next slide. We're going to address 4 major things here. First, what is this EPA 27 low NOx rule? And specifically, what problem are we trying to solve? What technologies are likely? And then other regulation that could be driving changes as well. Next slide. All right, I'd like to start out with this graph here. And as you can see, I think we've made just tremendous progress over the decades in terms of reducing NOx and PM. But if you focus on the most recent years, which is 2010 and 2027, that's where the change is coming. And it's worth noting we really haven't had any NOx changes in regulation since 2010. And at that point in time, it was 0.2 grams NOx. In 2027, the new regulation will be 0.035 grams NOx per brake horsepower hour. There's several other changes with this rule. Warranty, emissions warranty will increase. The useful life will increase. Test cycles will also change. But the key thing to remember here is we're going from 0.2 to 0.035. If you could go to the next slide, please. Um, ICCT has done a study, and I think this really describes what problem we're trying to solve. And first, I want to say that we're not implying that engines are not compliant by this slide, but they did some in-use testing in real vehicles and went out and measured NOx. And in several duty cycles, the NOx was higher than the zero point 0.2 limit. The graph here, or the illustration, I think is pretty self-explanatory, but under the light load, kind of low vehicle speed modes, startup modes, there's more NOx than what that zero point 0.2 threshold is. As you move to the right and get up to higher vehicle speeds, the engine's running a lot hotter, and the NOx is much more in line with what the regulators were intending. So kind of the name of the game here is, which I'll get to in the next slide, is to create heat in these light load conditions, because that's the deficiency right now. Something about SCR, SCR can be very effective and efficient if the temperatures are hot, but we're talking pretty hot, like 200 plus C, and in order to get, and so like these light load type conditions don't see that. So the name of the game is going to be create heat one way or another, and then that makes SCR efficiency where it needs to be. If you can go to the next slide, please. There's basically two different type of architectures which are evolving, as illustrated here. The left one is really pretty traditional, what we have today in production. And then and the name of the game there is to add some heaters. And on the next slide, I'll show you a schematic where two heaters have been added to the catalyst, which heats this after treatment up. On the right-hand side, the strategy is not to add heaters, but to add a second doser and a second catalyst. And going into the inlet of this after treatment device, you'll see a doser there. That'll be installed right downstream of the turbo where the exhaust is the hottest. And then a second catalyst will be added, and that could be either in the engine compartment, which is called close coupled catalyst, or in the main after treatment device. Stefan, if you can animate it twice, I wanted to make two more points. These two architectures I'm showing, I think, are the main ways that the industry is going. There's been talk about cylinder deactivation, variable valve actuation, those types of things. While they're potential, we don't see them being added here in 2027. And then also alternate fuels, which is the whole purpose of this boot camp. That's another way to reduce NOx, and you'll see that in upcoming boot camp sessions. If we go to the next slide, I'll share with you what we've actually found in terms of public information. So you can see on the top row, Cummins, PACCAR, and Volvo have decided to implement a very similar architecture. Again, that architecture is 2010-like in terms of the catalysts and the DPFs and things like that. They are adding a 48 volt heater, and in order to have that 48 volt heater, you need a 48 volt alternator. Kind of moving from left to right, if you look at the Cummins illustration, the two little green devices are the heaters. So they've got one coming into the DPF, and then the exhaust flow comes through the top device there, goes through the DPF, comes back through that silver looking pipe, and then there's another heater as it just enters the SCR. And basically Cummins, PACCAR, and Volvo have chosen a very similar strategy. One note to make is it looks like Volvo will be adding a 48 volt battery, at least what we've seen in terms of public information. We haven't seen that from the other manufacturers. On the bottom is the other strategy that's being taken, and that's this dual dosing, and that's what International is doing. I want to make a couple of comments. Again, this is all public searches that we've done, but it looks like International is really kind of designed a clean sheet engine. They describe it that way, and taken a different emission strategy than what's been taken in the past. Specifically, they're not going to have EGR, and they're going to try to make that engine as efficient as it can possibly be, and then look to the after treatment to do all of the cleaning up of the NOx. Relative to this low NOx rule, they've added two things. One is this doser, which is right downstream of the turbo, and then they've added a catalyst inside that box. I think it's important to note that it's likely we'll see some changes, definitely software changes, probably some hardware changes, because None of these applications yet are compliant to EPA 27, but we think this is the way the architectures will look. If you go to the next slide, please. We tried to kind of summarize the advantages and some things to look out. Now, again, NACFE is not in the business to do any benchmarking, so we suggest you talk to the OEMs. But some of the things we're looking at, if you look at the heater system, again, it's more of a traditional SCR type. There will be a slight increase in DEF, but not very much. And then most of the manufacturers are talking about a fuel economy improvement, and that could probably come through the engine or powertrain. I think the things to look out regarding this heater system are, will you see higher idle consumption, fuel consumption at idle? And then what about the reliability? We have a new device, the heater, and the alternator is at 48 volts, so that's something to keep an eye on. This third item here is something interesting and to keep an eye on, and no one has mentioned this, but with that 48 volt battery that I mentioned Volvo has, we could see over time a 48 volt battery being added to all of these applications, and then maybe a mild hybrid or air conditioning compressors or things like that running at 48 volts. Anyway, that's kind of how we see this heater system. The dual SCR, dual dosing, again, these are mainly things that have come out of the S13 engine. No EGR cooler, a simpler turbo. They'll have passive regen instead of active. And then they're claiming some pretty big fuel economy improvement. And again, that goes back to the fact that they're trying to make that engine as clean as possible, as efficient as possible, and then do the cleaning up of the NOx in the after treatment. I think the things to look out for are, will you see any kind of hardware change on that catalyst to get down to 0.035 NOx? The second, dose of reliability, that is in a very hot environment right next to the turbo, so we'll see how that pans out. And then since they're having the engine as efficient as possible and having the after treatment do the cleanup, there will be more DEF consumption. Go to the next slide. So far, everything I've talked about is this ultra low NOx, which is the main topic here. But I think we wouldn't be complete if we didn't mention that we've also got decarbonization coming along. So there's the greenhouse gas phase 3 and the CARB Act rule. You can see the information there on the left. Basically, that's going to drive different types of powertrains as listed on the right-hand side. So then on my right-hand slide, or next slide, please, I think it just opens the door for the future boot camps that we have coming. And the message is stay tuned, because I think we have a lot of, like Mike said, a lot of exciting sessions coming up on all these alternate fuels. So with that, thank you, Rachel, and I'll turn it over to the next speaker.
Sounds great. Thank you so much, Jeff. I so appreciate the presentation today, and we're going to welcome in our next speaker. This is Scott Fenwick. He is the Technical Director for the Clean Fuels Alliance America. Scott, thank you so much for being with us today. I'll go ahead and turn it over to you.
Thanks, Rachel. I appreciate that. And a huge thanks to Jeff. That presentation Jeff just provided is a great lead-in for what the information I'd like to provide you today. We can go to the next slide, please. And so really, we're at a point in time where fuel composition is changing faster than ever. But the one thing that is changing faster than the fuel composition out in the marketplace is engine technologies. And so that's going to be key. No longer can we look at just the fuels or just the engine technology. Everything has to be looked at in a holistic point of view. Huge thanks to these organizations I've got here on the screen. They provide a lot of the funding for what Clean Fuels does, particularly me and a technical program within Clean Fuels, and just want to provide you a little bit more information on that as we move forward as well. Next slide, please. So Clean Fuels Alliance America is the domestic national trade association for the biomass-based diesel industry. We represent stakeholders of biodiesel, renewable diesel, and even now sustainable aviation fuels out in the marketplace. We believe that these type of low carbon liquid fuels can provide superior performance, reductions in emissions in each and every application out there available for use. So not just over the highway and on-road, but off-road, locomotives, marine application, ag, construction equipment, obviously aviation industry, power generation, where electricity is needed, peaker plants, as well as home heating applications, open flame applications, such as in use in the Northeast. Well, I want to talk about where we're at today, but we believe that by the end of this decade, and our governing board set this vision back in 2020, we believe that by the end of the decade, we would reach 6 billion gallons of production and consumption in the US, avoiding over 50 million metric tons of CO2 greenhouse gas emissions. With advances in feedstocks, we also believe that we can hit 15 billion gallons by 2050. Now that's important in that basically the distillate pool consumed by the US is just under 60 billion gallons. So 15 billion gallons would be a significant improvement as we move forward. Next slide, please. It's important to note, though, that we're not going to see these changes uniformly across the country. Obviously, those different applications that I mentioned are going to see advances at different rates. Obviously, different markets are going to see different rates. But these are all the different aspects of what are going to influence us today. Certainly, if we look at the far right, policy. There is absolutely no doubt about this, that depending upon the administration, depending upon the regulatory agencies and their directives, policy will be front and center. Whether or not those are federal policies, state policies, carbon policies, mandates versus incentives. I mentioned we're addressing those markets. We want to ensure that each and every application, each and every engine, each and every manufacturer is comfortable with the data that we can help provide to ensure performance, to help meet those emissions requirements, ensure that the fuels and the systems are durable and compatible over their increasing full useful life. Obviously, we use different feedstocks. We are not petroleum based. And so we're looking at different feedstocks. Certainly the vast majority of what we utilize are virgin vegetable oils, such as soybean oil. And I reference that from our funding organizations as well. They've made a commitment here in the last year to expand upon the crush industry to provide more vegetable oils that are available for use in the production of renewable fuels. But it's not to say we're going to use it all. We want a wide variety of feedstocks, but certainly those food and feed markets need to come first. The renewable fuels industry was created after an abundance of these feedstocks, and farmers that got together around a table 30 years ago and said, look, we're producing enough protein, but what are we doing with the additional oils that we can produce? What are our options? And then certainly we look at production today. I mentioned, we believe that we can hit 6 billion gallons by the end of the decade, but I want to show you where we've come from as well. So next slide, please. Again, just over a decade and a half ago, we were well under 1 billion gallons, roughly 250 million gallons, which, as far as the fuels industry goes, is really not even recognizable out in the marketplace. However, for 2024, and we're expecting final federal numbers here in the very near future. In fact, we're projecting 4.9, and I've even seen later numbers to project that we're a consumption of roughly 5 billion, potentially 5.1 billion gallons here in this last year. Now, we do divide this. Again, the lower portion of that graph you can see is biodiesel. The upper portion has been renewable diesel. And so certainly the growth here in the last 4 or 5 years has been on that renewable diesel side. But make no mistakes, these are two separately and distinct fuels. They have their own specifications within ASTM and even in the global marketplace. And so we want to ensure that both fuels in all of these applications can meet the needs of the consumer. We also expect sustainable aviation fuels to start having a drag on these feedstocks as well. And certainly the marketplace will take that into consideration. What fuels are best used in different geographies, different seasons, and in different applications. One thing that's interesting to note, I mentioned the US uses roughly 60 billion gallons of distillate fuel per use, and we're at 5 billion gallons this past year. In certain other markets, we can go to that next slide, particularly out on the West Coast where they have low carbon fuel standards, such as in California. The latest numbers, about halfway through 2024 last year, California has now displaced over 70% of its petroleum distillate fuel use. In fact, between 70 and 75% of all the diesel fuel consumed in California is now made up of biodiesel and renewable diesel. So that's way above and beyond that 5% national average, or even approaching 10% that we are at 5 billion gallons. So we're going to see different markets, different geographies, but this gives you an indication as well as the type of policies that are in place. It's not just federal policy, but it's going to be state incentives, whether those are consumptions, mandates, such as were passed in Minnesota back in the early 2000s, and now we're coming upon SAF tax credits across the country as well. Next slide, please. So one of the things that we've pride ourselves here at Clean Fuels is working across, again, the different platforms, working with these different vehicle and engine manufacturers, but also improving the infrastructure. And so we're tracking those stations across the country in association with the Alternative Fuels Data Center, link here on your screen. But as of just last month, there are over 1,400 retail stations in North America offering B20 and higher blends. Next slide. We're also making advancements with the ASTM specifications and with the technical support. We've created new versions, new specifications for these fuels. We have low metals grade of biodiesel to help ensure that the emissions after treatment systems, again, can meet their durable and full useful life moving forward. We're looking at changes in the heating oil market. Next slide, please. As well as doing surveys of our fuel quality. We're doing annual quality surveys for both biodiesel, soon to be including renewable diesel. We're confident in the quality of these fuels against diesel fuel out in the marketplace. Last slide, next. And then just lastly, some of the advancements that we've made. We're proud to partner. We've recently included all 6 Class 1 railroads as membership in Clean Fuels. They now approve B20 blends and R50 blends and higher. And then the marine diesel fuel specifications on a global basis now incorporate B100 in their fuels as well. And so we're proud to partner with the entire industry. Rachel, with that, I'll turn it back over to you.
Awesome. Thank you so much, Scott. This was a great presentation. I'd like to keep the ball rolling here. We're going to introduce our third speaker. The next on our list is Colin Howler. He is the CEO of Optimus Technologies. Colin, thank you so much for joining us today, and I'll turn it over to you.
Perfect. Thanks for having me, and yeah, I appreciate the opportunity to present this morning. Next slide. So at Optimus, we build technology to enable heavy-duty diesel engines to operate on 100% biodiesel. Most engines today are compatible with biodiesel blends up to that B20 level, and that's a function of engine systems, the after-treatment control systems, as both Scott and Jeff had indicated, and also operational and logistical challenges with utilizing biodiesel at those higher blend concentrations. Next slide. One of the reasons that we focus on 100% biodiesel is there has been a strong pull from shippers in the market to decarbonize the supply chain. So ranging from companies like Amazon and Walmart to PepsiCo, many setting long-term sustainability goals with the objective of achieving net zero and interim targets that allow them to create a glide path to reduced emissions in their supply and logistics operations. Biodiesel is derived from things like waste oils and fats, as well as byproducts from the agricultural industry. And because of these biogenic feedstocks, the carbon molecules that are utilized in the production of biodiesel results in a very dramatic reduction in carbon emissions, and from scope carbon accounting can reduce GHG emissions by up to 100%. Biodiesel is also the lowest cost total carbon reduction solution. as well as overall the lowest full life cycle carbon emission strategy, as presented by an ATRI report a couple years ago. It's available nationwide, as Scott mentioned, over 1,400 stations that have biodiesel today, and utilizes the existing infrastructure. So one of the large challenges with alternative fuels is the ability to distribute, and those challenges are eliminated with biodiesel being able to be distributed in the same end use pumps and dispensers. Next slide. At Optimus, we build a technology that is an upgrade for existing diesel engines. So we can integrate into existing diesel engines or build into new trucks as they get manufactured. Most of the deployments that we have on the road today are actually integrated in new trucks as they get manufactured and delivered to the end customer. It's a dual fuel technology, so we never inhibit the operation on traditional diesel. We provide full flexibility for customers, regardless of routes or operating conditions, to operate on 100% biodiesel. Again, while never inhibiting that ability to run traditional diesel or any blend in between. We have over 1,100 trucks on the road today that have accumulated over 85 million miles. Next slide. The technology utilizes traditional diesel or renewable diesel to start up and shut down the engine. We use waste heat from the engine to condition the biodiesel. So from a driver's standpoint, it's fully automated and it's hands-off. They're going to get in, they're going to operate that truck just like it was a traditional vehicle. When they start the engine, it's going to start on traditional diesel. We'll use that waste heat to condition the biodiesel. When all the operating parameters are met, our technology will automatically shift from operating on diesel over to operating on 100% biodiesel. That operation on biodiesel will occur for the remainder of operation. And then when the driver removes the key from the ignition, our system will switch back over to diesel fuel. It flushes the engine and the injectors and shuts the engine down automatically. We utilize traditional diesel fuel during operation for active DPF regenerations. This ensures compatibility with after-treatment systems, the diesel oxidation catalysts, and the DPF regeneration events. Next slide, please. Any fleet who has previous experience with utilizing biodiesel, one of the first things that comes to mind is cold weather operability. Biodiesel, because it is made from things like oils and fats, has a tendency to gel at a temperature much higher than traditional diesel. Photo on the right there is actually some distiller's corn oil biodiesel at about -35 degrees Fahrenheit. We have deployed our technology into northern Canada, and prior to doing so, we wanted to validate and ensure that we'd have successful operation. So we took a number of trucks to a cold chamber facility in Columbus, Indiana, and took those trucks down to -35 degrees. We were operating those engines equipped with Optimus on 100% biodiesel successfully in those Arctic conditions. Next slide. In addition to the real world miles that we've accumulated, we also, in partnership with Clean Fuels Alliance and about a dozen other partners, did a 1.3 million mile study with ADM Trucking, evaluating diesel vehicles, 5, compared to 5 biodiesel B100 equipped vehicles. And we validated improvement in diesel particulate filter performance and operation, engine oil parameters, and no impact to the operational performance of the vehicle or impact to the cost of maintenance compared to the diesel baseline units. Next slide. Biodiesel is available nationwide. As Scott mentioned, there are about 1,400 retail stations that have B20 blends or higher. In Q1 of 2025, in partnership with Pilot Flying J, we're launching the first 3 retail B100 dispensers. Those will be in Decatur, Illinois, Des Moines, Iowa, and Dallas, Texas. One thing that many people don't know is that most retail stations that have biodiesel actually blend on site. So they have that 100% biodiesel product on site in a dedicated tank, and it gets blended into the dispenser on island. The ability to tap into those tanks is relatively low cost and quick to build. So the ability for B100 to scale at retail is very easy and able to do so quickly. Next slide, please. To ensure that biodiesel is not 100% biodiesel is not dispensed into equipment or vehicles that are not suitable to operate on, we have a technology we call Smart Fuel. It's an RFID reader and chip that are tied into the dispenser. Those devices need to handshake and authorize the transaction, and this inhibits drivers from being able to refuel B100 into a truck or piece of equipment that's not suitable. Next slide. Biodiesel has been around for decades. Fleets and shippers that are looking for decarbonization solutions are finding it to be the lowest cost, easy, and proven ability to reduce carbon emissions. We've got over 1,100 vehicles that are operating on the Vector system with 85 million miles and no disruptions to operations. But really, particularly with infrastructure challenges, there's no charging required when it comes to using biodiesel. So Rachel, appreciate the opportunity to present today, and just want to share that if anyone is in Las Vegas for the Manifest Future of Supply Chain and Logistics Conference, we should have a truck on display with our technology. So we'd invite anyone to stop on over. Thank you.
Thank you so much, Colin. This was great. We're going to round it off with our final presenter of the day, Mr. Andrew Gibson, who is the Global Sector Marketing Manager for Fleet and Global Brand Manager for Shell Rimula. Andrew, thank you so much for joining us today. I'll hand it over to you.
Thank you, Rachel, and thank you to my colleagues, Jim, Scott, and Colin, for the excellent presentations that we've just heard. So I'm going to talk today about the role of lubricants in truck efficiency, and also touch on the previous presentations to look at how lubricants are effective in the diesel powertrains that are today, how those diesel engines are perhaps changing in the future, and then also touch on the lubrication technology you would look into different lubricants and different fuels going forward. So if you just pass on to the next slide, when we look at the vehicle from almost where do we start in the world of fuel economy? There are many ways to improve the efficiency of your truck, and help reduce emissions. We're going to focus today on, like you say, the powertrain element, but the elements of trailer aerodynamics, the tractor unit aerodynamics, the tires, the wheels, the chassis, and also the day-to-day operating practices, they remain, and they will remain whatever fuel the vehicle is chosen to do. And that fuel efficiency, or a metric that we use, is around freight ton efficiency. And that's around the maximum payload that you can carry, or the maximum for the smallest amount of energy that you will be able to transport those goods. So if you look at then again the powertrain and the efficiency of that powertrain, and that's not only the engine but the transmission and the axle as well, how we bring those all those components together to drive the most efficient vehicle, and how that really comes to place and how that really comes to play. So what I'd like to do is, first of all, go to the next slide, please, is again look at the adoption rate of how things have changed over time. Because in this world of messy middle, we understand that there are lots of technologies out there, lots of competing technologies out there, and actually we first hear about things, and also how we see the decade of change that is happening. So it's quite interesting to look back at the NACFE results and see how things have changed, and how things have changed over the rate of time. So looking at the graph in the middle, the yellow thing about low viscosity engine oils, we know that low viscosity engine oils have been around for a while, and typically a 15W40. Now we're moving to something which is lower, either a 5W30 or a 10W30 product. And what we see, as we talked about EPA 10, quite significantly and quickly after that, it moved from about 10% adoption to in the 90s, and a quite high adoption rate today. And that's fundamentally the correlation between the amount of energy that is needed to move the powertrain and the viscosity of the lubricant, which the lower the viscosity, the lower the energy, and then therefore the fuel efficiency benefit. So as you can see, but the real learning is the rate of change and how people are understanding, and where fuel economy and fuel efficiency is becoming more and more on people's mind. You can see the behaviours of the leading fleets and how many of those have chosen to adopt that technology, and quite quickly over the last few years. What's also interesting within this is also the rate of adoption of the transmission and the axle oils. And the curve that's not on there, but very similar to the adoption of the low viscosity engine oils, is the rise in automated manual transmissions. And along with that is the lubricant that's been chosen to do that, which in this case is synthetic transmission fluid. And those adoption rates are very, very high very quickly. So you can see how the leading fleets have chosen a higher performance, longer lasting, low viscosity fluid, and they've chosen those quite quickly, and they've adopted those into their practices. So the last graph I want to show you is the light blue graph, or with the purple text. So that's low viscosity engine oil, but specifically the next generation under the guise of FA4. So that will be perhaps 0W30, 0W20, 5W30, 5W20. And those lubricants are much later in adoption, and even now only about 50% adopted within the leading fleets. And what we see is we expect that class to increase with the adoption of the EPA 27 engines. And as you could heard, with the challenges of how to reduce NOx and the function of temperature in that. So what is the function of temperature? How hot will the engine be operating? How hot and how long does that engine have to operate to meet the emission step? So not only with the initial engine, but the lifetime of the engine. So what we expect is that category to increase, not only from a fuel economy benefit, where you can see the viscosities are much, much thinner. So, but what the reason for showing that is the rate of change over a period of time. And as you can see, it's the messy middle. So these graphs are only the adoption of the leading fleets, when if you look at some of the profiles across the wider states and with the wider market, you see some of the adoption rates will be a lot less. So it's really showing the art of the possible and what is possible for the next generation of oils. If you move on to the next slide, I just wanted to highlight quickly. If you look at the adoption rates, that's great, but also in this world of messy middle and people are looking to make change, there are so many more options, and also, but there has to be a business case. You know, how much information, and this information is on the NACFE website. It's how much information is available, and then what is the relevant payback of that technology. In the shameless plug for lubricants, as you can see, the low viscosity, we see that is in the top right hand corner, that is a real must adopt based on the adoption rates, B, the amount of information that's currently available, and the relatively short payback, and also the ease of implementation of that payback. It's not a case of significant amount of training, there is not significant amount of measurements, there's not significant amount in changes to that powertrain or any of the adoption that needs to be done. It is a real fit and forget technology. And that's why a lot of the leading fleets chose to adopt it, and adopt it quickly over the last decade. And then just adding into the next generation of low viscosity FA4 lubricants, the payback time is very similar. The concept of ease to fit and forget is also good, but also there is less information available, primarily because less people have used that, but also there's been less adoption into the marketplace. But again, I can see that moving into the top right hand corner quite quickly. So if you think about, if you just move on to the next slide, please, around how this has all come together in a kind of vehicle, and this vehicle is the Shell Starship. This was a diesel engine vehicle, and as you can see, what we did is, using the concept of freight ton efficiency, it's moving the most amount of goods for the lowest energy and the greatest efficiency possible. And that was done by, in this technology demonstration vehicle, was bringing all those technologies together. we did use the FA4 technology, and that was one of the reasons we were able to get excellent results. But also we used trailer design, really excellent drag factor, aerodynamic improvements in both the tractor and the trailer unit, specific axle ratios, upgrading transmission and upgrading engine. And also the objective low rolling resistance tires to really drive that fuel economy forward. So that was fantastic. And then if you just move again to the next slide, this was the version 3 of the technology, and the point I want to make around in this very last slide. So the same concept of vehicle, but also looking to use a natural gas. So in this one, it was run on renewable natural gas, and this was the Starship 3.0. So the only thing that was really changed in this vehicle was the advent of a natural gas fuel and a Cummins X15 natural gas engine. So again, fantastic results and a real showcase of the technology. So back to you, Rachel, and thank you everybody for listening.
Awesome. Thank you so much for rounding us out, Andrew. That was fantastic final leg of our presentations here. And if I could have all of our speakers come back on camera here, we'll go ahead and get into the Q&A portion of this session. Just as I suspected, we have a very interested and engaged audience, which is awesome. I've been collecting your questions as you have been sending them in, and I don't think we'll have time to get to all of them, but I am collecting all of them, which is great. The first question that I wanted to raise was around warranty. And the question here is, let me see here. So we wanted to ask about added costs or insurance risks by doing drop-in fuel and whether or not the engine warranty is honored with the B100 kit. Colin, I believe that question came up during your presentation. So if you want to take the first stab, and by all means, anybody else, feel free to jump in if you have something to add.
Perfect. Yeah, no, I appreciate that. So I think there were two questions in there. I'll hit the warranty piece because I think that is one that comes up often, and then I'll defer to Scott there to see if he has additional thoughts or comments here. Engine manufacturer warranties are based on part and workmanship, so they are completely independent of fuel. So there's no impact on the engine warranties for the use of the Optimus technology or the use of 100% biodiesel. The engine manufacturers do reserve the right to not honor a warranty claim if the failure was caused by the fuel, and that's regardless of whether or not it was 100% ULSD or 100% biodiesel. And so so in short, no impact on engine warranties. And Scott, maybe defer to you. I mean, there's been billions and billions of gallons of biodiesel utilized. So.
Yeah, I appreciate that, Colin. And I would answer the same way. As Colin mentioned, engine warranties do not cover fuels, whether that's B0 to B100. If a fuel is the source of an issue, then it's the fuel supplier that could and should be held responsible. But the use of biodiesel in any concentration or renewable diesel, these new drop-in fuels, does not in and of itself void your warranties.
Great. The next thing, and this actually came in from a question that was submitted while folks were registering, and I thought that this was good. And Scott, I think that you had mentioned a solution to this, but somebody had asked if there are tools to find the pricing and availability of renewable diesel and biodiesel online. We had a couple of audience members ask they'd like to know about that availability for their specific geographic area.
Yeah, absolutely. I did have a link in one of my slides for the Alternative Fuels Data Center. That is a website that is run by the National Renewable Energy Lab and Department of Energy, where you can enter that website and you can search for biodiesel blends, you can search for renewable diesel blends, hydrogen, renewable natural gas, all sorts of different drop-in fuels that are available across the country. And that will pinpoint you to a map location, the actual retailer that is offering those blends. It doesn't cover price. Price can change and fluctuate on a daily, certainly a weekly basis. And so what they try and do, and we help facilitate, is tracking who is offering those. Now that's only for blends of 20% and higher out there in the marketplace today. So mandates like Minnesota B5 this time of year, or Illinois incentives, it's about B14, would not necessarily be covered under that website, but certainly blends of 20% and higher renewable fuels are.
Gotcha. Alrighty. And to Scott's point as well, wanted to make a note that each of our speakers was kind enough to send over a couple of resources that we are linking out through the session page on runonless.com. So if you're interested in exploring any of these resources that folks are referencing, be sure to head back to runonless.com. The next question that I'm interested in, and Scott, this one came up during your presentation. So we're looking at realistically what the competition between air and rail, what that demand does to what percent of the renewable liquid fuels could reasonably go to trucking. What are your thoughts about that?
Yeah, my crystal ball is a little fuzzy, but what I would say is certainly that competition in the marketplace and those partnerships will drive the innovation, drive the availability of fuels in certain geographies, certain seasons. And so if you are a fleet, I encourage you to reach out to your local fuel supplier. Ask what their availability is for local fuels in your marketplace and express interest. Certainly Clean Fuels has some information on our website that'll be available for you with producers of these renewable fuels, whether they're biodiesel, renewable diesel, sustainable aviation fuels, available across the country. And so if your local fuel supplier doesn't have an agreement in place already, help them reach out to a local renewable fuel supplier and begin that partnership today.
Great. This is another question that came up during your presentation as well. And this one is more focused on the carbon emissions that are associated with feedstocks and the amount of land that is dedicated to feedstock growth. So somebody had asked how much farmland would be required to produce the 15 billion gallons. How does it compare with the farmland that is currently dedicated to ethanol? And I guess we'll start there and we'll just kind of build from there.
Yeah, I mentioned, we're interested in a wide, diverse amount of feedstocks. So whether that's corn oil from an ethanol producer, soybean oil from crush facilities, used cooking oil that's gathered and collected across the country, rendering facilities that offer poultry fat, beef tallow, pork, we can utilize all of those fats and oils in the production of renewable fuels. And so certainly, again, different fuels, different producers are going to be interested for various policy reasons. Certainly cost of the feedstock is a matter of fact, but certain policies favor certain feedstocks. What are considered used or waste feedstocks tend to get what's called a lower carbon intensity score that may have a higher value in the marketplace with some of these policies. And so what I would argue, though, is as a fleet or as an end user, not to focus on that so much. Certainly your local fuel suppliers will be utilizing any and all available resources to them. So utilizing certain feedstocks is kind of akin to saying, hey, I want diesel fuel made from a certain crude oil. Nobody asked for that. We expect that the fuels to be fit for purpose, available, meeting consumer expectations. That's what's of concern. So we want to ensure that the quality meets the appropriate specifications, that it meets the durability, compatibility of today's engine technologies, maybe your seasonal requirements for cold weather operability, but focus less on feedstocks right now as opposed to just helping us partner with those producers, growing the volume of renewable fuels out there that will enable more and more volumes for everyone.
Mm-hmm. Yeah, and if I can, I just maybe jump in with two additional points here. One, I think the question referenced ethanol production, and I think it's important to make a delineation there. With biodiesel, particularly biodiesel that utilizes agricultural byproducts, soybeans are the largest in the U.S. and soybeans are grown for the protein. The bean itself is about 80% protein and 20% oil. So there's a constant demand for more protein that continues to increase the volume of oil that's available for biodiesel production. So.
Yeah, thanks, Colin. Yeah.
Yeah, no, that was great. And I one of the questions that just came in is very interesting, and I'm interested to see. So somebody had asked how much of the biodiesel, how much of it requires or relies on imported feedstock versus how much of that is domestically grown.
Numbers as of this morning, what we have seen is a significant drop in imported feedstocks here over the last couple months. And so I would say less and less. Certainly fuels, just like whether it's petroleum-based fuels or renewable fuels, they are a global commodity, relying on global supplies of feedstock. And so I would have told you 2 months ago that we were probably 15%, maybe upwards of 20% reliant on imported feedstocks. Today, I think that number is less than half of that. And so certainly we are looking at producing higher and higher volumes of renewable fuels. We're going to need higher and higher volumes of those feedstocks. But as of today, due to global domestic supply and trade agreements, it's actually less than 10% imported feedstocks.
I see. Okay. I'd like to pass it over to Andrew. We only have a couple of minutes left here. Somebody had asked, Andrew, during your presentation, what is the average fuel economy improvement on low viscosity oils in both the engine and the powertrain?
Yeah, great question. It depends on the situation and the viscosity and how you're going to compare, but certainly I'll get the exact figures for you, but you can look between 1.5% and 2% when you compare that. So it's of that order. And then as what you've been able to see is if you compare with starting with a 1540 baseline viscosity, as you move to a thinner and thinner oil, then the greater the benefit from the viscosity change.
Great. Okay. And at the risk of running out of time, I have one more question here. So somebody had mentioned, Jeff, that you referenced several technologies for NOx reduction in your presentation. They said that they're curious to know if there are resources, reports, or links that show the mapping of NOx emissions with respect to torque and RPM. That they haven't seen any such mapping recorded, but wanted to see if you knew of any resources like that.
NOx to torque and RPM. I'm not sure I've seen some. I've certainly seen reports on, different fuel types and their impact on NOx. And I don't have them off the top of my head, but I'm sure we can find that. I'm not sure about the torque and speed. I don't know if any of the other panelists have seen anything like that.
Gotcha. And we can always, if we do find some resources like that, we can always link them in the session page on runonless.com too. So we'll do some digging, and if we find them, we'll put them there. But I know I have about a minute and a half left, so we want to go ahead and wrap up. Stephanie, if you could click to our very last slide here. So thank you everybody for joining us on the beginning of our journey here. Remember to go back to the landing page of this session on runonless.com. The quiz is currently linked. The button that you clicked to register, it is currently a quiz button, so make sure that you take your quiz. Connect with us on social media. We have all of our social media handles linked here. And we appreciate all the time that you've spent here today. We hope that you will join us for our next session, which will happen in 2 weeks. It's titled Decarbonizing with Natural Gas. Now have a wonderful day, and we'll see you in the next one. Thanks, everybody.